This is Brian Murray and I want to welcome you to another episode of Doc Bry, the Physics Guy. Hi everyone and welcome to this week's podcast, which is a bit of a strange one for me because after 30 years, yes, 30 years, Liverpool are once again the league champions. The last time they won, I had a full head of dark hair and more energy than a Duracell battery. I mean, I've been a Liverpool fan all my life, and when I was a kid, it was great. I lived about a mile from Anfield, which is home of the mighty Reds, and so I could walk to the ground on match day. If I close my eyes, I can still see every part of the journey in my mind. I had a paper round. Well, actually, I had 3 paper rounds. I did a morning, an evening and Sundays, so I could afford to pay to get in, buy ciggies, have a hot dog or a pie. I mean, happy days. On top of this, we won just about everything. It was just so easy. And then 2 things happened, though I don't think they're related, but you never know. The first was that I started my PhD, and the second was that Liverpool stopped winning the championship. The years passed and I finished the PhD and I went out into the world, and Liverpool continued not to win. Years turned into decades and my hair went from dark to grey and my waistline grew with each passing year. And then Jurgen Klopp arrived and everything changed. It's odd because Jurgen's arrival happened around the same time that I decided to have a change in my life and come back into physics. So here we are, 4.5 years later. Liverpool are league champions again, and I'm lucky enough to be coaching people in physics. I mean, life really doesn't get any better than this. Happy days. Well, apart from the coronavirus lockdown thing, of course. Liverpool is an amazing place, and over the years, some amazing people have actually studied and worked at the universities. I say universities because there's actually 4 and 2 cathedrals. One guy was James Glover Berkeley, who won the 1917 Nobel Prize for Physics 4 years before Einstein won his. Berkeley was born in Widnes near Liverpool, which makes him a worryback. If you know a Scouser, ask him what I mean. It's a Scouse thing. He went to school at the Liverpool Institute and then attended Liverpool University before heading to Cambridge. Berkeley won the Nobel Prize for his discovery of the characteristic Röntgen radiation of elements. Röntgen radiation was named after Wilhelm Conrad Röntgen, who was also the first recipient of the Nobel Prize for Physics in 1901. He got the prize for his discovery of Röntgen rays, and he really was a remarkable man. And in 2004, the International Union of Pure and Applied Chemistry named element 111 of the periodic table after him, Röntgenium. His discovery has had a massive impact on the world, and yet if you ask people about Röntgen rays, many have no idea what they are, even though they're used every single day in most hospitals. Most people have heard of them, they just don't recognise the name, and this is partly because they tend to go by the name Röntgen give them. See, it seems because he was a bit of a modest bloke that he was a little bit uncomfortable with them being named after him, so he called them X-rays, the X indicating that they were unknown at the time. The first recorded X-ray was taken by Röntgen of his wife's hand on the 22nd of December 1895. The image still exists, and it must have blown Röntgen's mind when he first looked at it. I mean, the first human X-ray. In 1906, Charles Berkeley discovered that each element had a characteristic X-ray spectrum. It's a bit like a fingerprint, and each element has its own unique X-ray spectrum, its own fingerprint. It was this work that won Berkeley the Nobel Prize in 1917, and this in itself was an amazing piece of work and well worthy of a prize for sure. We sort of take X-rays for granted these days, and they're mostly associated with broken bones. I mean, most adults have probably been for an x-ray or two over the years. I mean, I had an x-ray to confirm my broken wrist as a kid. I also had one taken when I fractured my head as a kid. I mean, come to think of it, most of my x-rays were taken when I was a kid, apart from my chest x-rays that I got thanks to being a smoker, which I started when I was a kid. I wasn't the brightest kid, that's for sure. X-rays are amazing. Marie Curie, my all-time favourite scientist and winner of 2 Nobel Prizes, developed a radiological car. This was like an ambulance with an x-ray machine in it, so soldiers could be x-rayed to help battlefield surgeons figure out what treatment was required. X-rays have also led to me mum finding out my wife was pregnant with my second daughter. It also shows that my sister is a genius. This is the story. I used to sit on my wheelie chair and spin around with my eldest girl, who was about 15 months old at the time, and she loved it. I mean, so did I. It was just great fun. She used to scream. She was so happy. Well, one day, as I was going to sit down, the chair slipped and toppled over, and me and my daughter fell, and her foot got crushed. I mean, luckily it was only bruised, but to be on the safe side, we were advised to go for an x-ray. So I'm telling this story to my sister, and I'm explaining that my little girl was a bit scared, but they let me put a lead shield on so I could stay in the room and hold her hand while they did the x-ray. With that, my sister says, "Sorry, Bri, something's come up, I've got to go." So I said, "Yeah, okay, cool, goodbye," and put the phone down. About a minute later, seriously, only about 60 seconds later, my mum's on the phone asking me why I haven't told her that my wife's pregnant. My sister has figured out that the only reason I would be in the x-ray room and not my wife is if my wife was not allowed in the x-ray room, and the only reason why she wouldn't be allowed in the x-ray room is if she was pregnant. At which point she'd hung up the phone on me and called me mum to tell her the news. Seriously, I kid you not. If you want to see information travelling faster than the speed of light, just tell something interesting to one of my sisters. So, what are x-rays? Well, they're just photons of light, but they're short wavelength and high energy, and as a result we can't see them with our eyes. They carry so much energy, in fact, that they can damage living tissue. John Hall Edwards, a pioneer in the use of x-rays in medicine, had to have his arm amputated in 1908 due to x-ray dermatitis. You can understand why they wear protective clothing these days and stand in a separate room. X-rays can be produced by firing high energy electrons at metal targets. The targets are made of materials such as tungsten, molybdenum, copper, silver, gallium and indium, and each produces an X-ray at a very specific frequency. I mean, this is all great and much of this is taught at school, but I really didn't get X-rays and just how cool they were until I was doing my PhD. X-rays and the things you can do with them led to a number of Nobel Prizes. Barclay in 1917 and Röntgen in 1901, we've already mentioned those, but Max von Laue won it in 1914 for his discovery of X-ray diffraction, and the Braggs, father and son, won the 1915 prize for the diffraction law and loads of other clever stuff. It was this diffraction law that really blows my mind. My PhD was based on strontium, yttrium, barium, copper oxide thin films. These films were deposited onto these fantastically smooth single crystals and were really thin. They range from about 10 nanometers to a micron. Now a micron is a millionth of a meter in thickness. That's a thousandth of a millimeter. One of the things we wanted to discover was the dimensions of the crystal structure of the yttrium, barium, copper oxide. The problem is that these dimensions are tiny. They're typically less than 1 nanometer, a billionth of a meter. So how exactly do you measure that? I mean, you can't use a tape measure, that's for sure. The process that you actually use is called X-ray diffraction. You basically load your sample onto a table and bombard it with X-rays, and you rotate the table through about 180 degrees. At certain angles, you get lots of X-rays coming through, and this is called constructive interference. And if you know the wavelength of the X-ray, which we did, there's a real simple formula for working out the size and orientation of your crystals. And in this case, this was my yttrium barium copper oxide thin films. Now, it's one thing reading about the process, and it's another seeing it in action. I was amazed when I'd get the results from the X-ray experiment and be able to perform the calculations and get the crystal values. At the time, the results came on a long sheet of paper that was almost 2 meters long, and it just contains loads of spikes. The x-axis would be the diffraction angle and the y-axis would be the intensity of the diffraction rays. I was able to measure atomic level distances accurately. I remember grinning all day long like I'd been the one who'd actually discovered X-ray diffraction. I mean, it really was a happy day. The other thing that I found was that after doing this about a dozen times, you got really good at spotting the peaks of various orientations, and you'd be able to jot them on a sheet of paper really quick so that you could do like preliminary calculations and get some results before you took them away for sort of closer inspection. It was fantastic. I mean, to have access to this type of equipment and knowledge was just fantastic. It really was brilliant. Lawrence Bragg, the son, was 25 when he did this, and he won the Nobel Prize with his dad and remains the youngest recipient ever. He died in 1971, shortly after me and Jürgen Klopp turned 4 years old. I used a law that he discovered, Bragg's law, as part of my PhD research. How amazing is that? This is Dr. Bry, the physics guy. Hey everyone, this is Dr. Bry, the physics guy. I hope you enjoyed this episode. If you did, can you share it with your friends, your fellow students, and anyone you think might be interested? That'd be great, and you'd be doing me a massive favour. Subscribe now so that you don't miss out on the latest episodes and news, and check out my website right now at drbry.com. That's drbry.com. And for a limited time, I'm giving away the first part of my 7 ingredients course. It's absolutely free. There's almost 40 minutes of free video explaining the course and why you have what it takes to do physics and how it can change your life forever. And there's also a free download that you can keep. All the details are on my website. I'm also on YouTube, Instagram and Facebook, and all the details are there on drbry.com, drbry.com. I look forward to seeing you soon.